Okay, students. Now we are going to discuss the nature of the infinite series. Either the given infinite series is convergent or divergent using Cauchy's root test. Okay. So about the infinite series, the definition and some basic properties already we discussed in the previous video. Now we are going to test or we are going to find the nature of the given infinite series that we denoted by summation un using Cauchy's root test. Now, how to test whether the series is convergent or divergent using Cauchy's root test? If summation un is a series of positive terms and if limit un raised to 1 by n as n tends to infinity equal to lambda. First, from the given series, we write the nth term, that is un. Then taking that nth term un, we take the power as raised to 1 by n. Then we take the limit as n tends to infinity. So in this function of n, we substitute the n equal to infinity. So before putting n equal to infinity, we are going to simplify this. After the simplification, we put n equal to infinity. We get some value of the limit, say that lambda. Then the series is convergent. We say that summation un is convergent if the value of the lambda is less than 1. If the value of the limit is less than 1, then we say that summation un is convergent. Okay. And the value of the limit lambda, if it is greater than 1, then we say that the summation un is divergent. Okay, so remember the conditions. If the value of the limit is less than 1, then it is convergent. If the value of the limit is greater than 1, then it is divergent. And there is a one more condition: test fails. Means this Cauchy's root test fails to say that whether it is a convergent or divergent when we get the value of the limit as 1. Okay, so remember the conditions. I repeat again. We take un, that is a nth term of the given infinite series. Then we take the power as 1 by n. Then we take the limit as n tends to infinity. We first simplify before putting n equal to infinity. Then we substitute value as n equal to infinity. We get some value. If the value is less than 1, it is convergent. If the value is greater than 1, then it is divergent. If the value is equal to 1, then test fails. Test fails means, so by this Cauchy's root test, we cannot say whether it is a convergent or divergent. So then there is another procedure to check the nature of the infinite series. So here is that. If a test fails for lambda equal to 1, then use the order test. What is this order test? So this is nothing but the comparison test. So this comparison test already we discussed in the previous video. Okay, so what we do, see, here is that comparison test is what this un will be given in the problem. From that we choose vn. How to choose vn? Here is the formula: 1 divided by n raised to p minus q, where p is the highest power of n in the denominator and q is the highest power of n in the numerator. So taking this vn from un, we check this condition un by vn, taking limit as n tends to infinity. The value of this limit must be non-zero. If this condition satisfied, then we see the nature of summation vn. If summation vn 1 divided by n raised to p, okay, we get Vn in the form of 1 divided by n raised to p, then we say that it is a convergent when p is greater than 1 and it is divergent when p is less than or equal to 1. Depending on the value of p, we say that it is a convergent or divergent. If summation Vn is convergent, then by this comparison test, summation un is also convergent. If summation Vn is divergent, then summation un is also divergent. This is what we say comparison test. Okay. So here, when test fails, means when lambda value is 1, then we apply the comparison test or we apply the fundamental test. Either we apply any one, either we apply the comparison test or fundamental test. Then what is this fundamental test? So fundamental test is what? If summation un is convergent, then limit un as n tends to infinity equal to 0. Means what we do, when Cauchy's root test fails, we take un, we take the limit n tends to infinity, we evaluate this limit. If the value of the limit is 0, if the value of this limit gets 0, then we say that summation un is convergent. This is what we apply the fundamental property. Means we're just checking this limit, the value of the limit summation un as n tends to infinity is 0 or not. If it is 0, then it is convergent. If it is not equal to 0, then it is divergent. Okay, so therefore, if the Cauchy's root test fails, we apply the either comparison test or fundamental test. Okay, and if nth term of the series containing the nth power, then apply the Cauchy's root test. So this is one point which helps you to apply the Cauchy's root test. Means whenever we have a function of n in the form of f of n to the power again function of n. Okay, this you try to understand, because depending on the nature of the infinite series, we apply the test. Okay, the nature of the function of n in this case is f of n. So this is the function of n. Again, the power of this must be function of n. Okay, if this is in this form, then we apply the Cauchy's root test. Okay, remember this point. Now, so these are the some standard limits. Okay, so these standard limits will help you in solving the problem. Okay, now we take the problems on the Cauchy's root test. Yes. So here is the first problem. The question will be asked as test the convergence of the given infinite series. See, summation n equal to 1 to infinity 1 plus 1 by n to the power n square. So this is f of n, it's a function of n, and even the power of this is also again function of n. So when this is the case, we apply the Cauchy's root test. Okay, so our un is 1 plus 1 by n to the power n square. Then by Cauchy's root test, what we do, we take to the power as 1 by n. We take both sides to the power 1 by n. When we take that to the power 1 by n, so this 1 cancelled, we get 1 plus 1 by to the power n. Then by test, we take the limit n tends to infinity un raised to 1 by n equal to limit. So in this also, we take limit n tends to infinity for 1 plus 1 by n to the power n. We have the standard limit 1 plus 1 by n to the power n as n tends to infinity value is e, and we know that the value of e is 2.718 something. Okay, so the value of e is 2.7, means that must be greater than 1, right? When e is greater than 1, by the Cauchy's root test, it is divergent. Okay, when summation when the value of the limit is greater than 1, then it is divergent. Okay, now This is one example. Second example, summation 1 plus 1 divided by square root of n to the power minus n raised to 3 by 2. So un is given directly. So taking the un, then take the power as 1 by n. Okay. So 1 plus 1 divided by root n to the power minus n raised to 3 by 2, then to the power 1 by n. So these two terms are multiplying. Okay. So this I write here, minus n raised to 3 by 2 to the power 1 by n. When we multiply these, okay, so minus n 3 by 2 divided by n, okay, and this again we write as minus n raised to 3 by 2 minus n minus 1. This is minus n raised to 3 by 2 minus 1 is n raised to 1 by 2. So this minus as it is, and we get n raised to 1 by 2. Okay, when we took 1 raised to 1 by n, then this we can write as 1 plus 1 divided by square root of n to the power minus square root of n. Now we take the limit on both sides, limit as n tends to infinity. So 1 plus 1 divided by root n to the power minus root n. So that we can write as a reciprocal 1 by 1 plus 1 divided by square root of n to the power root n. So again this is in the standard form. The value of this limit as n tends to infinity is e. So 1 by e. So that is 1 divided by 2.7. So that become less than 1. When the value of the limit is less than 1, then by Cauchy's root test it is convergent. Okay, this is the second example. Now this third example is different from first and second, because see, in this infinite series we are having x. So here x is the variable, right? Now summation n equal to 1 to infinity n plus 1 into x to the power n divided by n raised to n plus 1. So un is this, taking un, then take the power 1 un raised to 1 by n. When we take to the power as raised to 1 by n, and that one adjustment we did here, 1 plus n plus 1 to the power into x divided by n raised to n I take into n raised to n I took inside this bracket, and this whole raised to n, and 1 by n remain, that I wrote. When we take to the power 1 by n, this cancelled, okay, and this n cancelled, 1 by n raised to 1 by n I wrote here. Then taking the limit n tends to infinity on both sides. Okay, so before putting n equal to infinity, we take the highest power of n common in the numerator, also in the denominator. When we take n common from this, 1 plus 1 by n remain, and x as it is, n as it is, n raised to 1 by n. So this n cancelled. Now we are putting n equal to infinity. Okay, 1 plus 1 by infinity, 1 by infinity is 0, x as it is, n raised to 1 by n. This is again one standard limit, the value is 1. Therefore we get x. So here x is not defined. By Cauchy's root test, suppose the value of x, which is not defined, suppose if we assume that the value of x is less than 1, then by Cauchy's root test the summation un is convergent. If we assume that x value is greater than 1, then summation un become divergent. Okay, and if we consider x equal to 1, then test fails, because in the Cauchy's root test the value of the limit is 1. We say that test fails. When a test fails, I suggested in the beginning, either we apply the comparison test or we apply the fundamental property. So here I applied the comparison test. When x equal to 1, we take x equal to 1 in the un. So that un we consider, in that un we put x equal to 1, we get un equal to, say here it is, n plus 1 to the power n. X is 1, okay, 1 plus n plus 1, x is 1 to the power n divided by n raised to n plus 1. Okay, now taking n raised to n as common, 10 to the power n raised to n, and this from this n raised to n cancelled, 1 plus 1 by n to the power n, and 1 n raised to 1 remain. Okay, so this is un. From the un we choose a vn. So here I wrote directly. So from this un, vn is given by 1 divided by n raised to p minus q. So here p is what? P is the, it's a power of n from the denominator. The power of n is 1. Then power of n, so we do not have any n term, so n raised to 0. So n raised to p minus q. P is 1, q is 0. So therefore we get vn as 1 by n. Okay. Then directly we are taking un is this is vn. Vn is of order 1 by n. Okay. Then by comparison test, both summation un and summation behave alike. Okay, so that we can verify, that is taking summation un divide limit un by vn as n tends to infinity. If you check this, this must be not equal to 0 you get. Then both behave alike, summation un and summation vn behave alike. Therefore this vn is what? 1 by n, where p equal to 1. When p equal to 1, summation vn is divergent. So when summation vn is divergent, so summation un is also divergent, because p equal to 1. So therefore the final conclusion is summation un is convergent. So here it is said it is convergent when x is less than 1, divergent when x is greater than 1, and also for x equal to 1. When x equal to 1, we applied the comparison test. From that it becomes divergent. Okay, so therefore it is divergent if x is greater than or equal to 1. So this is the way we do whenever the infinite series containing x term. Okay, now we take the next problem. Yes, 1 by 2 plus 2 by 3 into x plus 3 by 4 whole square x square plus 4 by 5 raised to 3 into x cube plus so on up to infinity. This is a given infinite series. So here in this problem the un is not given directly, so we need to write the nth term of this infinite series. So what we do in some kind of problems, we need to avoid some terms. So here by avoiding the first term, we consider from the second term, then only we are able to write the nth term of the given series. So you're omitting the first term. See that un, the first factor we have 2, 3, 4, 5. These are the first factors. Applying for 2, 3, 4, a plus n minus 1 into d, we get n plus 1 for the first factor. Next I take the second factor 3, 4, 5. Apply a plus n minus 1 into d, you will get, see, okay, here I write, we have the factors like 3, 4, 5, so on. Here a equal to 3, d equal to 1. A is the first value of the series, d is the difference between these. So then a plus n minus 1 into d, this is the nth term we are writing. A is what? 3 plus n minus 1 into d is 1. So this is n, 3 minus 1 is 2. This is n plus 2. This is the way we write the nth term. Then similarly for x square, x cube, and so on, we write the nth term. This is a simple, that is x raised to n. So we got un. Okay, now we write the by Cauchy's root test, un raised to 1 by n, we take the power as n by n and also taking the limit as n tends to infinity. When we take that to the power as 1 by n, this n cancel and also this n, we get n plus 1 divided by n plus 2 into x because the n cancelled. Then before putting n equal to infinity, we take highest power of n common from the numerator and also from the denominator. That n and this n cancel, we remain 1 plus 1 by n, and here also taking n as common, 1 plus 2 by n, and this x as it is. When we put n equal to infinity, 1 plus 1 by infinity is 0, 1 plus 0 is 1, again 1 plus 2 by infinity, this term becomes 0, then 1 divided by 1 is 1 into x. We get the value of the limit as x. Okay, now we check the conditions. By Cauchy's root test, if we assume that if x is greater less than 1, then the summation un is convergent. If we assume that if the value of x is greater than 1, it becomes divergent. And if we consider x equal to 1, then Cauchy's root test fails. When test fails, either we apply the comparison test or we apply the fundamental property. See, by the fundamental property, what we do, we are putting x value as 1, then that un becomes, so in this we are putting x equal to 1, n plus 1 divided by n plus 2 to the power n. Then here we are applying the fundamental property, taking n as common, n cancelled, 1 plus 1 by n to the power n, 1 plus 2 by n to the power n. Okay, now we take the limit as n tends to infinity, then 1 plus 1 by n to the power n, this is the standard limit we have, the value is e, 1 plus 2 by n raised to n, this value will become e to the power 2, then the value becomes 1 by e. The value of the limit is what? Not equal to 0. When the value of the limit is not equal to 0, by fundamental theorem, the summation un is divergent. Suppose if the value is 0, it becomes convergent. If it is not equal to 0, then it becomes divergent. Therefore, finally the conclusion is what? The given series is convergent when x is less than 1 and divergent if x is greater than or equal to 1. This is the example. Now, we consider that one more example, that is 2 square by 1 square minus 2 by n to the power minus 1, 3 square 3 cube divided by 2 cube minus 3 by 2 raised to minus 2 plus 4 raised to 4 divided by 3 raised to 4 minus 4 by 3 to the power minus 3 plus so on. Okay, see how we are, see writing the nth term is a very important point in this. We are going to consider the factors one by one. The factors, see that we have 2, 3, 4, these are the factors here. Okay, so taking 2, 3, 4 as a factors, apply a plus n minus 1 into d, we get n plus 1. Okay, that we can verify. Then consider these terms 1, 2, 3, 4 and so on. The nth term is n. Then for this term and this term, the power is what? 2. Okay, see 2 by 1 raised to 2, 3 by 2 raised to 3, 4 by 3 raised to 4. Therefore the terms are 2, 3, 4, 5. For 2, 3, 4, the nth term is n plus 1. That you can verify applying the formula a plus n minus 1 into d. Okay, the next one is 2, 3, 4 and so on. The nth term is n plus 1, 1, 2, 3. The nth term is n. Then see, for all the brackets we have the powers minus 1, minus 2, minus 3, so on. Therefore here the nth term is minus n. So this is the un we wrote. Now we are going to check the nature of the series applying the Cauchy's root test. We take the power as 1 by n Okay, we have to the power minus n, so that n cancelled, we left to minus 1. Okay, from these two terms I take the common n plus 1 divided by n to the power n as a um, as common. Okay, sorry, 1 n plus 1 divided by n to the power 1 as common from this and this, and we have the common power as minus 1 that comes here. Then what we left, n plus 1 divided by n, this n, this we took common, we left 1 to the power minus 1. Then n plus 1 divided by n to the power minus n, taking the reciprocal, that can be written as n by n plus 1 into, taking the reciprocal of this, 1 divided by this term. Again in this term we took n as common. When we take n as common, n cancel, what or else we can separate 1 by separating the terms, 1 n by n 1 plus 1 by n, we separated the terms to the power n, then minus 1. So here also taking n common in the denominator, n cancelled. Okay, 1 divided by 1 plus 1 by n when we take n common from this. Now we are going to put n equal to infinity. So this is 1 divided by 1 plus 1 by infinity is 0. So 1 by 1 is 1. This is 1 divided by 1 plus 1 by n. This is the standard limit is e, and this minus 1. So 1 divided by e minus 1, it is a less than 1. E is taking as a 2.7. 2.7 minus this 1 point something we get, so 1 divided by that is less than 1. So when it's a value of the limit is less than 1, by Cauchy's root test, summation un is convergent. Okay, so these are the examples on the Cauchy's root test. Thank you.